Okay, quiet please. Quiet. Listen up. Okay, so today we go to two-step equations. And obviously that means you're going to have to do two things to solve. Okay, what does it mean to solve an equation? It means to isolate the variable on one side. The answer should be on the other. Right? How do you isolate? Adam? You do inverse operations, right? So if there's a multiply going on, you divide. If there's an add going on, you subtract. So whatever it takes to undo the operation that's there, you do the inverse of it until you're isolated. So now we're going to have to do two steps. And really the only question is, like if I've got to do a divide and a subtract, then which goes first? No. Okay. So which operation to do first? The answer is do it in the reverse order of PEMDAS. So in PEMDAS, you do a multiply before you do an add, but in solving equations, you undo the add before you undo the multiply, right? So just think of it like PEMDAS, but just, it's reverse. So addition and subtraction now come before multiplication and division. Okay, so let me show one. So here we go. So what is the variable? The variable is x, and it's got a couple different things going on that side of the equal sign. It's being divided by 2, and there's being a plus 5. So again, you got to decide which one of those should you undo first. Yeah. Okay, so we're gonna get rid of the plus 5. Before we get rid of the divide 2. So how do you undo a plus 5? Subtract 5, right? So show work. Minus 5, right? That's from the whole side. Okay, so what does that leave us on the left? Not x over 2 equals 6. Okay, now the x is still not isolated. What do I have to do? Times 2, right? The x is being divided by 2, so now we're going to multiply both sides by 2, right? So times 2, right? On the left, the 2 in the numerator cancels the 2 in the denominator. On the right, I got 12. Okay, so you try that one. So again, there's two operations going on. Which one do you undo first? The plus 9, right? Plus 9 before divide 5. So minus 9 undoes a plus 9. 5x equals 15. And then divide both sides by 5. And if you got any trouble with the math, like 15 divided by 5, just put it in the calculator, right? Get it right. Okay, try another one. Okay, what was the first step? First step. We want to get rid of the negative minus 7, right? And what's the inverse of subtracting? Add. So we add 7, add 7. Negative 1 plus 7 is 6. Okay, now we've got to divide 3. What's the inverse of dividing by 3? Multiplying by 3. Both sides. So the 3's cancel, and z equals 18. Okay? So sometimes one of the operations is to combine like terms. And it's important that, we're going to move on. From two steps, we go to multi-steps. We go to variables on both sides. And it's really important that before you start adding terms from side to side, that you actually take care of all the like terms that are on the same side, right? And adding like terms does not involve, adding twice to the equation, right? That's a common mistake that we see, that you think you're going to cancel one of those terms by adding the opposite, and then you do it twice, but you did it twice on the same side of the equal sign. So you never want to do that. Remember, combining like terms, you don't have to add to both sides of the equal sign. Like in this one here, we have, what are the like terms? 7x and 4x are like terms. What is it that makes them like terms? The variable is the same, and it's raised to the same power, which means you can combine them. How do you combine 7x minus 4x? Yeah, I mean, literally, you do like this, right? 7 minus 4 times x, which is 3x. You probably don't show that step, and that's okay, but that's what's going on. I mean, think of it like this, right? 7 apples minus 4 apples. How many apples do you got? 3 apples. Okay. Now that was our first step. I didn't add to both sides, right? I just took care of business on one side, and now I still have to get rid of what? The 3. Okay. So how do I get rid of it? Divide. So make sure, because I've seen this mistake also just going around, that when you say you're going to divide 3, that it's a divide 3 on both sides, so you don't just for some reason subtract 3 on the other side. It's got to be the same thing. Then 21 divided by 3 is 7. And if you're not sure about that, use the calculator and get it right. Okay, so here's your U try. Solve by combining like terms first. Okay, what did you get for an answer?
4.
X equals 4. So before I do this the right way, I just show you this is the common mistake that we'll see, usually on a more complicated problem like this, because you don't get this kind of problem on any test. But this is what students will do. They'll go minus 2x minus 2x. What's the matter with that? You actually subtracted 2x twice on the same side of the equal sign. So now your equation's all out of balance. It's not going to work. So remember, you got to just think of it, when you see variable terms on the same side, combine before you start trying to, add to both sides. And that would save you this mistake. So what was the right thing to do? Yeah. How do you add 4x plus 2x? You add the coefficients, right? That's the name for it. The number in front of the variable, add the coefficients, which is 6x. And then you divide. X equals 4. How could you check to see if that was the right answer? You could put it up here, right? You could put it in there and see whether it leads to a true statement. I have a feeling you're kind of experienced at that. Try that one. Positive 4, right? So you subtract these, you get negative 4. And then you divide by negative 4. D equals 4. Okay, next. Quiet, please. So this one combines a little bit of words and algebra. The output of a function is 3 less than 5 times the input. Find the input when the output is 17. What variables do we usually use for input and output? So which is the input? X is always the input, right? So when they say the output of the function is 3 less than 5 times the input, you could just say that the output is the y, the input is the x. So how can I write this? Is 3 less than 5 times the input. So the 3 less is minus 3. 5 times the input is 5x. And all of that equals y. So first you write the equation, right? Now, what do you have to do when it says find the input when the output is 17? What do you Right? The output is y. You're going to take that 17 and put it in the place there. 17 equals 5x minus 3. Okay, now that's a two-step equation. Solve it. What should I do first to solve it? Plus 3, plus 3, 20 equals 5x. Divide by 5. So x equals 4. So you got to set it up a little bit. You got to remember, we did this function stuff. We did inputs and outputs and domains and ranges and things like that. Hey, Hunter, right? You don't need to chat now. You guys get together after school and chat. So you try to do that one. Similar kind of setup, right? Right? The equation should have been y equals 4x minus 4. 4 less than 4 times the input. Substitute y as 3, and then it's a two-step equation. Add 4, divide by 4. And it's okay to leave it as 7/4. That's fine. That's almost preferred. Okay, I think I got one more. Okay, this is our word problem. This is our real. Anybody do scuba diving here? No. You're living right next to the water? You want to do scuba diving? Okay, listen up. Right? As a scuba diver descends into deeper water, the pressure of the water on the diver's body steadily increases. So the deeper you go, there's more pressure. There's more weight on top of you. Right? The pressure at the surface, quiet, right? The pressure at the surface is 2,117 pounds per square foot. The pressure increases at a rate of 64 pounds per square foot for each foot the diver descends. Right? Find the depth at which the diver experiences a pressure of 8,517 pounds. So what are the two variables here?
Square feet and pounds.
Say again?
Square feet and pounds.
Well, the pressure, they said, is in units of pounds per square foot. So that's pressure, right? So we need a variable for pressure. Guys, Cal. So P is going to be a variable. We'll call that P for pressure. And then what does pressure depend on then? The depth. This is called D is for depth. So now we're going to write an equation. Which is the input and which is going to be the output? What are you trying to find the value of in the end? Well, pressure. We want an equation for pressure, right? So the pressure is going to be, what is it at the surface? So that's the starting point. And then it's going to increase for every 1 foot of depth. It increases, right? How much does it increase for every 1 foot? So it's plus 64 D. So now they're saying find the depth at which the pressure is 8,517. So let's substitute pressure. 8,517 equals 2,117 plus 64D. Now the numbers are a little bigger, but it's still just a two-step equation. Try to solve that. You go ahead and do it. Definitely you want to use your calculator. What's the first step? What's the first step? Remember, you're going to do the subtract before you do the divide. So subtract 2,117 from both sides. Okay, what did you get when you subtracted 8,517 minus 2? 6,300? Yeah, I think it's 6,400. Come on, Connor. Equals 64D. Okay, last step to solve this thing? Divide 64. Divide 64. So what does D equal? 100. So at 100 feet, the pressure is 8,517 pounds. Ouch. So I think you need a suit or something. So that's it. So the answer was 100. Okay, so there's your homework. Show work for full credit.